All right, guys, my next question I kind of cut off the top here, but if you look at your actual notes that I sent, says a well-designed experiment reports that 27%. So I'm going to right away talk about my p-hat. My p-hat is 27%. 27% of 53 subjects. So my N, my sample size, is 53 subjects. Report improvement after using a new medicine. So a new medicine comes out. 53 people are asked a question, and 27% of them say that they have improved after taking this medicine. So right away, I can now find that my Q hat is the remainder of my 100%, and 100% minus 27% is 73%. So what we're going to do here is we're going to find the 95% confidence interval, the 90% confidence interval, and the 99% confidence interval. This guy right here, this letter A, we can do it with our normal curve. And I can also show you a way on your calculator that gets you a tick more accurate. But this normal curve is close enough for our answers. Now, 90% confidence and 99% confidence, we actually have to use one more new button on our calculator, so make sure you have that handy with you. And we're going to find how many z-scores, or what our z-score would be if we want to be 95% or 99% confident and 90% confident. How many standard deviations would we have to be above or below the mean? So the very first thing I'm going to do is I'm going to calculate my standard deviation. Holds true with what we've done for 3 weeks. So pause the video if you need to come up with your calculations. When I typed mine in, I got 0.06098, which I'm going to make this 1. So about a 6.1% change in my for my standard deviation. So I want to do this with formula for a second so we can understand what that is doing with my formula. I'll show you a picture in a second, but right now we are expecting that 27% is my true proportion because I knew that 27% of this sample said that. We want to go above that and we want to go below that because we are now looking for the margin of error. Where would we have to be off? How far are we off to become 95% confident that we actually grabbed the real answer in there? Well, if I want to be 95% confident, I really can go out 2 standard deviations below and 2 standard deviations above. So I can technically put a 2 right there. Now remember, my standard deviation, I already calculated, but it's right there. But if I want to use my formula and not actually come up with that estimated answer, that 0.061 came from doing 0.27 times 0.73 all over 53. So now look back here for a second. Look, I just did this. P hat plus or minus, because above or below, how many standard deviations I was, which was my z-score, multiplied by my standard deviation. So when you type this in your calculator, I'm going to do 0.27, and then I'm just going to do the plus 1. So plus 2 times, I still have that in my calculator as my previous answer. So I can push second negative to come up with my previous answer. And what I got there was I got 0.39, which is 39%. And I'm going to do the same exact thing, but I'm going to do the one that's the minus. I'm going to do this guy, 0.27 minus 2 times my square root of alpha y equals, to come up with that, my 0.27 times my 0.73 all over my 53 people in my sample size. And what I got that to equal 0.142. 8, which is about 14.8%. So I am 95% confident that the true proportion of my population that would report improvement would be between 15% and 39% of the population. I'm going to state that again. I am 95% confident that the true value, the true percentage of people who are going to get better from this medicine is 14.8% of the population, all the way up to 39%. I have a 95% confidence that it is somewhere between those two numbers. Now, I want to be 90% confident. I want to be 90% confident. So let's think. Is that going to lower our margin of error or increase my margin of error? I want you to think. It's actually going to, my values are going to shrink in. If I'm 90% confident, I'm a little less confident. So I'm actually going to be maybe like inside here. I'm going to go from this range. So my number is going to have less range between them. So the one thing you don't know how to do is find that z-score right now, and we have a button in our calculator that will do so. So I want everyone to find your calculator, and I want you to put second vars, which remember gets you up with your distribution list. So I'm going to type that in. You're going to push second, and then you're going to push the vars button, the one we've been using for quite some time now. Now, on number 3, you see inverse norm. And what this inverse norm button does is it's going to give you the z-score for what we call now is we're doing our 90% confidence interval. So where it says area, you want to have 90% of your curve under that. So you're just going to type in 0.90. So the first thing you're going to have is you're going to have area, and it's going to be 0.90. You change nothing else on your screen, and you're going to leave it in the center because we want this to be in the center of our normal curve, some above and some below. So what you should be seeing, area equals 0.90. You should have mu, your mean at 0, your standard deviation is 1, and you're going to go off on the center. You're going to paste that in, and what you see is negative 1.64 to 1.64. This is what you see, which means if you're in a 90% confidence interval, your z-score, you are 1.64 standard deviations above the mean, or you could be 1.64 standard deviations below the mean. Long story short, your z-score is 1.64. So again, I'm going to erase that curve that I showed you, and I'm going to do that curve one more time now that we have that number. So if we know that this sample population had a 27%, and we want to go not 1. So if this is 1, and this is 2 standard deviations above, and this is 1, and this is 2 below, 1.64 would be something like this, something like this. We want all of this range right here is what we're looking for in this case. We're kind of closing it in a little bit. So remember your formula is 0.27 because that's what we got. We're going to add and we're going to subtract. Remember, it is my 1.64 standard deviations above or below the mean. And we can go ahead and we can put that formula in there again. We could put this guy here. We could have it calculated from before and just type it in as the calculated number. The first thing I'm going to do is above. I'm going to type in my calculator, 0.27. I'm going to add 1.64 of those standard deviations. So second, I'm going to get my square root. I'm trying not to estimate here. So 0.27 times 0.73 over 53. And I got 0.35. So my upper end is going to be 35%. I'm going to do the same thing with oh, I screwed that up, didn't I? Some of you are probably going, what the heck? Because I had 0.25 typed in, not 0.27. I apologize. This should be 0.37. Hopefully you caught my mistake. so which is 37%. I'm going to do the same thing, but I'm going to do my 0.27, and I'm going to subtract 1.64 times my standard deviation. And I got down here, I got 0.169999, which is about 17%. So I am 90% confident I'm going to grab my true proportion of the data if I'm somewhere between a 17 and a 37%. I want you to compare. I shrunk it in a little bit. I was between 15 and 39, and now I've shrunk it in to be between 17 and 37%. So I'm 90, I shrunk in my little window. That makes me a little more, or a little less confident that I grabbed that actual true proportion. So then last one I'm going to do here together as a group is I'm going to do this 99% confident. Think, if you're 99% confident you grab your true proportion, you're really going to go all the way out. So I want you to realize, if we're in here in this curve, and I am at 0.27, and I want to be 99% confident I get my real answer, I'm going to be way out here. So to get how many z-scores it is, we know it's going to be darn close to 3 z-scores because that was 99.7% accurate. So we're going to do our second VARS button again, and we're going to go down to number 3, which is inverse norm. And we're going to type in that our area is 0.99, and we're going to leave it in the center. So you're going to go second distribute. You're going to arrow down to number 3, which is inverse norm. You're going to type in 0.99. I'm just going to go all the way down to paste and push enter. And it gave me negative 2.57 to 2.57. So not quite 3 standard deviations above and not quite 3 standard deviations below, because that was 99.7 confident. But darn close to 3 standard deviations above or below. So my last part here is I want to be really confident, 99% confident, so I'm widening that range up a little bit. I take my 0.27, I'm going to add or subtract. Now remember, go to your calculator, how many groups of standard deviations, how many of those numbers we're going to add in or subtract in that 2.57. Remember, your standard deviation has not changed. So the first thing I'm going to do is I'm going to go on the high end, 0.27 plus 2.57 standard deviations. I'm typing in my standard deviation. Y'all should be doing the same thing. And I got a 42.7. I'm going to do the exact same thing. I'm just going to push second enter, which pulls up my calculation that I just did. And I'm just going to go change that plus sign that I had in there. I'm going to change it to a minus sign. And I got 11.113. So that is 11.3% and 42.7%. Notice I widened my range. So now my statement would be this. I am 99% confident that the true proportion of people that will improve from this new medicine is somewhere between 11.3% and 42.7%.